All right, should be good to go. Evgeny, why don't you introduce yourself and your topic for today for this professional services enablement session?
Yeah, for sure. Thanks very much, Glenn. So I'll quickly introduce myself and introduce the session, and then we'll move on with the actual content. My name is Evgeny Rudinsky. I'm a senior professional services engineer here at GitLab. And today's topic is about the CI/CD, GitLab CI/CD components for deploying infrastructure in Azure clouds using what is called a DSL or domain-specific language Bicep. So it's going to be a little bit about the Bicep kind of 101, what you can do, what you can do, what's the difference between other infrastructure as code languages, as well as the CI/CD components, like how to get them, how to get started with the CI/CD components, and a little bit about the component that I built. And I think it might be useful for my colleagues and for those who is looking for the way to deploy infrastructure in Azure cloud using this approach, like using the approach that is outlined in the component. So basically, you test it, you lint it, you execute a validation against the actual cloud and see if everything is valid, so then you can deploy. So that's what is included into the component. But let me maybe do things one by one, and start with a little bit of story, like why actually I decided to kind of go down that path. So sometimes working at PS, I'm interested to get to spin up quickly Omnibus, just for some testing, and it could be not the latest Omnibus, but basically the Omnibus, like for example version 16 something or 15 something. So some of the old version, because I want to make sure that the config that I have at hand is compatible with what I'm trying to achieve. And I was thinking, like, how can I approach that? Well, obviously, the simplest way would be to spin up a virtual machine, or maybe to spin up a Docker container already with the binaries of Omnibus, and then proceed with the tests. But then I thought, well, what if I want to kind of get quite powerful VM, which can handle the load that I need, let's say like 500 users or 5,000 or 1,000 user, then yeah, I would need a proper like underlying infrastructure for that. And then, well, cloud provider is one of the choice. And then again, like I can approach that in a manual way. So basically I can go to the cloud provider, do some ops, click ops work. So provision the virtual machine, get all the ports in place, and then install the binaries of the Omnibus. But that is actually very time consuming. So I think the actual configuration part as well as the infra would take maybe 10, 15 minutes, depends how fast you can copy paste things and then get things together. And then the other maybe 10 minutes to get the actual binaries of GitLab to be installed. Well, and then I thought, okay, what if I can build maybe a template? And then I started to think, well, I can do with Terraform, I can do maybe with I don't know, like file formation if it's AWS. And I started to think about what if I revisit my old friend Azure Bicep and build the underlying infrastructure and maybe a little bit of the configuration management, because the basic setup of GitLab would be very basic, yeah, shell script. So you pull some information and then you install it on the VM, and that's pretty much it. So that's how I ended up with this approach, with everything that I'm going to show you. And as I said, you might find this useful for whatever type of work you do, because yeah, the end idea would be to get the GitLab Omnibus up and running pretty quickly in Azure using this approach. And then again, because there is already component in place that you can reuse, so you can do it yeah, with all the different jobs that I have prepared and put there. So you can test it, you can lint it, as I said, validate it, and then eventually deploy that. Okay, so that's a little bit of story. So what is actually Bicep? Well, Bicep is a domain-specific language. So it's a way to describe your infrastructure in a way that you desire to get it. So in this case, if let's say you want a specific virtual machine with the specific tier, if you want a specific storage attached to that virtual machine, if you want to get the security groups configured in a way that you want, let's say you want to open up the HTTPS, you want to open up the SSH, so then you can get connected to that virtual machine. So those kind of things you can configure and put as code. And then Azure Bicep used to be, well, Azure Bicep is relatively new. I believe it's maybe 3 years, yeah, 3-4 years. So it used to be always IRM or Azure Resource Manager, where you can describe things that you want to spin up in Azure. And then if I switch to my editor, I just want to quickly show you what is Azure Bicep. Maybe I can put next to Terraform. And then, yeah, we can just take a look at this together. So basically over here, so that's a very simple resource. So as we can see here, it's a storage account. It uses a certain version of the resource manager, and then it defines the name, the location of the resource that we plan to deploy using this approach, and then SKU, kind, and then we can also define some other parameters. So pretty much similar what we can do using Terraform with the Azure provider. So if you can compare that, it's pretty good, readable. So it also has the resource, the targets for the deployment, like the resource group, location, account tier, etc., etc. Well, this is not one-to-one, but this is kind of idea of what it can be. Bicep on the left and Terraform is on the right. And then I also previously mentioned that it used to be an IRM template. And if I open this up next to my Bicep, you will see that it's much more complicated. So that probably was one of the reasons why Microsoft started to invent that Azure Bicep to like simplify things and to give a language which is possible to use to declare the infrastructure in a simplest way and understandable, and it's easy to follow. So again, like this used to be IRM, this is still in place, this is widely used, and then this is the equivalent of that IRM. So things are much shorter, and I think what you see on the left is easy to follow, easy to read, and kind of you can predict what's going on here. So I'll just do a quick demo here, like with what it is exactly when you get a resource described in Bicep, and then when you try to deploy that, because here we need a target. Maybe a quick comment about this picture. So in Azure, there's a concept of different scopes. So you have management group, you have subscriptions, you have resource groups, and you have the actual resource. On any of these scopes, you can deploy resource. So for example, you can deploy to the management group, let's say the role assignments. If you want to give a specific role to a specific group or to a specific user, you can deploy that in form of resource. You can deploy to subscription, you can deploy to resource group. So usually the actual resources like virtual machines, managed resources, storages, so you deploy them to the resource group. And then this is called scope, and you can define scope. You can define scope also when you deal with the infrastructure as code template. So you can define where the template should be deployed to which scope, either management group, subscription, resource group, etc. So if I return back, just to quickly to my example. So here, this example is the storage account. And the storage account we can deploy to a resource group. So therefore, in order to deploy that to the resource group, I actually need to create the resource group. I'm gonna quickly run this command. So I can say that AZ, so that's a command line interface to to work with the Azure cloud. So I have logged in my Azure CLI already with the target account, so then I can actually access the subscription and I can start deploying the resources. So what I'll do quickly, I'll just create this resource group in the North Europe. So I'm just passing the resource group name and the location of the resource group. And then the next command will be the actual deployment of the resources that I have defined here in my Bicep file to the target. So the command is relatively simple to follow as well. So it's AZ deployment group create. So then you do the target, which is the PS enablement RG. So this is the resource group that we created with the previous command. And then we pass two things. So one is the actual template, which is the main Bicep. And then the second thing here is the parameters. So if I quickly revisit my parameters, so I have only name. So that's the name that will be given to my storage account. So it's pretty simple example, as I said. So I'm just gonna run this deployment and see if I can get the storage account deployed. So in this case, what we deploy, we just get the what is called Azure Blob deployed with this SKU. So that's a premium locally redundant storage, I guess. So yeah, we got a storage account deployed. If I switch to my Azure portal, so the Azure portal is where you can just go ahead and check the resources. So that's the resource group that we have created, and that's the actual storage account that has been deployed. One little thing that I think would be nice to highlight is the state. So usually, if folks on the call are familiar with Terraform, so we have a thing called a state. So Terraform state basically is the file where we keep the state of the deployment. So in this case, Azure Bicep doesn't have that concept. So the state, well, there is a concept of state, but the state is kept in the actual scope of the deployment. So in this case, if I go to the resource group here, so the deployment that we did, well, it was defaulted to the main deployment name. I can actually pass the name, but I kept it simple. So that's the state. So this is the state of my deployment. So if I look at the template, okay, so I don't have permissions for this user, but that would be a template that has been deployed, and that would be various parameters that I passed for this particular deployment for this particular resource. And the state is kept here, right in the scope, right in the target. So moving back. Let's talk a little bit about the CI/CD component. So what I just said here, well, that makes sense because you can describe more complex resource. Well, actually, before CI component, let me jump here and show you quickly show you how I describe the Omnibus setup. So basically, it's a little bit more advanced, let's say, template here. So we've got a bunch of different parameters that we are passing, but again, because it's pretty easy to follow and read what's going on there, we can see that we've got a network interface card. We've got a network security group where we define here, okay, we want SSH, we want HTTP, HTTPS to be exposed, so then we can access this particular resource from the public internet. So I do it because I want, to access the UI of my GitLab instance. So then we have virtual networks, we have subnets, we have public IP addresses, we have virtual machine resource. So yeah, and then this basically defines the whole resource and set the whole resource which is needed to launch a virtual machine. So there are some associations between them, like pointing to a specific disk, pointing to a specific network interface, and so on and so forth. And then the last piece that I have here is just a way to leverage an extension, which is run a specific command after the deployment of the resource. So in this case, I just follow what we have in the user guides for the deployment of for the installation of the GitLab binary. So basically, we get an update. Yeah, so it's what is stated in the documentation. So I'm mimicking that approach to get GitLab installed. So how I can deploy that? Well, I can deploy that using the same approach. Like I said, you can just create a resource group that's going to be a target for the deployment, and then you pass the template along with the parameters like we just did for the storage. But what if I want to make it as code? Well, I can push it to code, but what if I want to do some other things, like I want to validate it, I want to test it, I want to see what would be potential result if I try to deploy that to the target. So maybe the same resource exists, or so basically to do all these kinds of validation before I do the actual deployment. And then I started to think, so maybe I should craft a reusable template, a reusable model. A reusable pipeline. And then I ended up with the concept of the CI/CD component. So if we switch here, so the concept of the CI/CD component for in GitLab is that you get a logic which is defined in the YAML file, in the pipeline file, which is doing some builds, storing the artifacts, doing different manipulations. And the idea of the CI component is that you can actually reuse that. You can reuse it and you control the behavior, you can control the outcome of the execution of the pipeline, which uses the CI/CD component with its open outcome. And you can control that using parameters, using either parameters in the parameters file, or using the parameters that you have defined in the actual component. And then, as I said, like I started to look into the into this and started to think about how I can make it useful for others at the same time following like how typically industry is doing that. So, and this is the example of the component that I built to deploy resources that we just deployed manually. But this can be placed in the pipelines, and then you can get all sort of jobs here that are, for example, this is the SAST for infrastructure as code. So it's going to validate whether you have anything that is crafted against some security recommendations. So, for example, you open up all ports to the worldwide from the virtual machine. So that's going to be flagged in the SAST report, and we're going to look into this just in a minute. But yeah, the CI/CD component that you see right now on the screen contains the following steps. So yeah, basically it builds the template it converts the template to the format that the scanner from GitLab understands. So in this case, we use Kix for scanning the resources. So then it provides you a result of that scan saying that where you have to maybe improve your templates to make it better, more secure. And then here are like a couple of jobs where we say that okay, so we can link the templates. We can also mimic the deployment, basically logging in with the targets, setting up the account to the subscription, and then deploying or mimic, trying to deploy, like trying to do the what if, what's called, to the target, like trying to understand what will happen if we deploy that particular template to the target. So then we can do validation, and then there's the actual deployment, and then there is a job that destroys the resource that's being deployed. So that's one component. And if I just go back, so there are actually two components that we can use today. So one component is following the service principal authentication. So in Azure, what you can do to authenticate your automation against cloud, against specific scope, you can create a service principal, and then you can give it a specific, you can put it at a specific scope, and you can give it a specific role. So for example, you don't want to give owner role, but maybe contributor role, depends on the use case. And then in order to make your automation to work, you would need to create a couple of, you would need to pass a couple of parameters here, a couple of values here. So basically you would need subscription ID, tenant ID, Azure application ID. So that's kind of username, if I simplify that. And then eventually you would need to give a token or passwords. So these parameters are needed to authenticate your logic against the desired target environment. So that's why we see here in each job the authentication with the service principal. So we can see that it's a service principal authentication. We authenticate using the username and password, and then we pass the tenant. And then later on, we use the subscription because you may have multiple subscriptions within tenant. So that's one method. So basically, you get a service principal, and then the other approach would be to use OIDC. So what you can do is that you can configure OIDC Connect in Azure. So then you can trust to a specific action which is happening to it. So you would need to pass a couple of things on the Azure side to make sure that it's federated and it trusts to the script or to the automation that you're trying to run. And then this will be basically equivalent of using service principal. So the end result will be authenticated session temporary token that is being used for the automation. And then because this approach is available in Azure, so I thought, what if we build the same template or the same component for using this type of authentication? So here, if we look a little bit closer at what are the inputs required, so we would need only tenant, again, just because we need to make sure that we work with the right tenant. Then you need a subscription because eventually we want to deploy the resources, and for that we need a subscription at the target. And then we only need the application ID because like a username, because the rest will be done by the federation inside Azure. So what we need to do is just we need to annotate here how we're gonna obtain the OIDC token, and then this is basically how it's done. And if you look at the documentation that I showed earlier, so there's a very good explanation how to configure the federation to work and to trust. So there is a branch involved and the specific project, so from where the actual automation will try to obtain that token. Yeah, so these are two authentication methods that we can use or reuse in the component. So, and then now going back to my use case that I said. So again, from time to time, I want to get Omnibus up and running quickly without too much effort to get the infrastructure up and running and get the config applied. So I just use something like this. Let me show you. So I got this pipeline example. So what it does, it basically reuses the component that I just showed you. If I go to the to web IDE, so I'll just quickly show you how exactly I use the component. So that's exactly what is stated here. I go to the component itself. So there is a way, there's an explanation how you're going to use that. So like basically that's how you can include the component, and then that's how you can pass the inputs to your component. So there is a way also to use a legacy approach where you can include that using the project, the reference, and the specific file, and then pass the variable. So both options are available. And then if I go to my use case again, so what I do here, I'm just reuse the component. So a couple of things that I pass is the location of the template. So in this case, I got it here in Omnibus, and then that's exactly the Bicep template I showed you with the old components for the virtual machine. So you get a virtual machine, network interface card, network subgroup, etc., etc. So then I point to a specific file, and I point to the parameters that I want to pass along with my deployment. And then I just run it. So what you see here is basically the deployment of different versions. So and then the way I control it is if I go to my parameters file. So here I do have a bunch of different parameters that I can use to control the desired state of my deployment. So you may see something like the password for GitLab and password for the actual virtual machine. So I keep it simple. So I pass it via the variables right here, just to, again, keep it simple and easy to follow. Of course, these things usually you keep in either CICD variables or maybe Vault or maybe other secure place that can be easily pulled, and then you can pass this information in a secure way to your automation. So in this case, I just use it like this so that it's easy to follow. And then over here, that's how I control what I want. I can also control this by, like, I can also control the edition and the version. So then it will be placed all together. If I scroll down here into this line here, so basically it will be substituted and then passed in the correct way. So then I can get the correct version of the GitLab deployed. Very simple way, but again, the idea is that I really want, let's say, 17.3.1 with the SSL certificates publicly accessible, and and then I can just do it. So so this one has been deployed an hour ago just to save time because it's like 12 minutes. And if I go to my Azure right here, so it was Omnibus RG. So maybe just quickly jump to the ED just to remind you. So we use this Omnibus RG as a research group. So that's the target for all these deployments, for all these resources to be deployed. And then if I go to the resource group, so these are all individual resources that I've deployed. And then the top one, that's the virtual machine. So if I click on the virtual machine, it gives me this DNS name right here. So basically, that DNS name that I can use to access my my GitLab. Well, I already tried to access it. So I logged in, but trust me, that's the virtual machine that has been deployed. Just an hour ago, basically, with using this automation. So we can also quickly go to this RG deployment. As you can see, it was run at 3 p.m. And so that's the deployment. That's the URL. I can access it, and if I go to admin, I can see that exact version 17.3.1 Enterprise Edition. So then I can proceed with my tests and see how I can use it. Maybe quick comment here. So if I go to ED again, I try to keep it. I try to make sure that I follow the reference architecture. So for single VM or up to 1,000 users, if we go to the reference architecture, we would see that that's the recommended tier on Azure. So I just put by default, that one in my template. So then I can comply with all the load, and it will just work as expected. And I can proceed with my tests. So that's pretty much it, I think, what I wanted to demonstrate. I put together everything in this public repository. So the example for the storage, the example for the Omnibus deployment, feel free to revisit that, as well as the way to use the CICD component. So you can take a look at this yourself. In the meantime, I'll just start destroying the virtual machine that has my Omnibus so that I don't burn money on Azure Cloud. That's it. Thank you very much.
And thank you for your fiscal responsibility. I appreciate that. Keeping those machines turned off. Awesome. Any questions for Evgeny right now? I don't see any in the documentation, any comments or anything come through on the chat. Okay. Is there an example project or any code or any of these documentation you can link us to in the enablement documentation?
Yeah, I've already done it. Maybe it's in the title, but I will move it down. But there is a link to this repo. Maybe I can just quickly go ahead and share that in the chat, and then we can pin it.
I see it. Okay, I moved it down into the actual session stuff too. Perfect.
Thanks.
Perfect. All right, awesome. Thank you very much. Any other questions? Comments? Excellent. Well, as always, if you do have anything that you think about as you're looking through the video or just pondering what you've seen here today, please reach out, either comment in the documentation or reach out to myself, Glenn Miller at GitLab, and I will be happy to get those questions forwarded and see if we can get those answered for you. Really do appreciate it. Take care all. Thank you. Have a great weekend.
Bye.